Hey guys, it's Miss Adams, and we're wrapping up our Algebra 1 midterm review for the 2022-2023 school year with our exponential functions. So we're first going to focus on just the characteristics and how to apply how to identify exponential functions and geometric sequences. So if I'm looking at f of x equals 4 times 3 to the x minus 5 power, in order to determine a reflection, I look at my a value. It's positive, so there's no reflection. Growth or decay is determined by my b value, which in this case is 3. 3 is bigger than 1, so this will be a growth. And then I'm going to look at my a value again for stretch or shrink. So I've had a, b, we're at a again. 4 is bigger than 1, so this is going to be a stretch by 4. I then need to look at my h value to determine that horizontal shift left or right. I have x minus 5, which aligns with our exponential function where it says x minus h. So this is going to shift right by 5 units. My k value is going to determine both my asymptote and my vertical shift up or down. In this case, my k value is 0, so I don't have a shift up or down because it's by 0, and my asymptote is at y equals 0. For number 2, it says negative 1/4 times 2 to the x power plus 2. Our a value is negative, so it does have a reflection. The b value is bigger than 1, so it's a growth. That 1/4 is less than 1, so it's a shrink by 1/4. We don't have a horizontal shift here, so it's not going to go left or right any. Our k value is 2, so it's going to shift up by 2 and give us an asymptote at y equals 2. For number 3, our initial amount is 2. Our change factor is 1/2, and our asymptote is at y equals 1. For number 4, our initial amount is 1/3. Our change factor is 2, and our asymptote is at y equals negative 4. For number 5, we're going to use a table function in our calculator. So I'm going to press table, and I'm going to enter in 1/2 to the x power plus 3. So when x is negative 2, y is 7. When x is negative 1, y is 5. When x is 0, y is 4. And when x is 1, y is 7/2, which is the same thing as 3.5. So if I graph that, I've got negative 2, 7, negative 1, 5, 0, 4, and then 1, 3.5. I also know I have a horizontal asymptote at y equals 3. So I'm going to go ahead and draw that asymptote in and then connect my dots. Looking at this is a decay, but also my b value is less than 1. My asymptote is above that x-intercept, so I'm not going to have an or above the x-axis, so I'm not going to have an x-intercept. My y-intercept in this case is 0, 4. My domain is going to be from negative infinity to positive infinity, but my range is going to be from my asymptote at 3 to positive infinity. As I look at the end behavior, on the left-hand side of my graph, that's when x goes to negative infinity. My y value is approaching positive infinity. And on the right-hand side of this graph, as x goes to positive infinity, my y value is approaching 3. For number 6, identify the equation for the graph given the exponential function. I know I have a horizontal asymptote at y equals 0, which automatically eliminates b and c. And this is a decay function, so the only one that works is a. For number 7, I know a can't work because it doesn't have an x in it. Then, if I'm looking at my common ratio here, I'm increasing each time by 3, so I'm multiplying by 3 each time. So I know that my change factor needs to be 3, so that's going to go ahead and eliminate d. But then I need to look at where I start, and in this case, I'm starting out at the value of 2. So the only correct answer here is C. For number 8, it says write the first terms for the geometric sequence. And when I'm looking at geometric sequences, this is given the explicit form, meaning that my 2 value here, excuse me there, guys. 2 is my initial value, so that's my a sub 1. And my common ratio here is 3. So I know I'm multiplying by 3 each time, starting with the number 2. 2 times 3 is going to give me 6. And 6 times 3 is 18. For number 9, it says write the first terms for the geometric sequence given that your initial value is 4 and your common ratio is -5. So 4 times -5 is going to give me a -20, And negative 20 times negative 5 is going to give me 100. For number 10, it says write an explicit formula for the geometric sequence and then find the 10th term. Well, I know my initial value is 7. And in order to find my common ratio, I can do 14 divided by 7, which gives me 2. So I have 7 times 2 to the n minus 1 power. And now I need to find 7 times 2 to the 10 minus 1 power. So in my calculator, I do 7 times 2 and raise it to 10 minus 1, which will give me a value of 3,584. For number 11, I'm going to do the same idea. My common ratio is going to be 25 divided by 50, which is 1/2. So my a sub n is going to equal 50 times 1/2 to the n minus 1 power. And I'm going to do 50 times 1/2. And in this case to the 10th power, so I need to raise that to the 10 minus 1 power. And that gives me a fraction, so I'm going to convert that to a decimal of 0.09. I'm just going to round it to 0.098. Guys, it says write a recursive formula for the geometric sequence. I know my initial value is 2, and each time I'm I'm multiplying by 2. So my recursive formula is going to be a sub n is equal to a sub n minus 1 times that r value of 2. If I'm writing the recursive formula for the geometric sequence for number 13, I know my common ratio is going to be negative 30 divided by negative 10. Negative 30 divided by negative 10 is 3. My initial value is negative 10. So I have a sub n is equal to a sub n minus 1 times 3. If I wanted to write an explicit formula for the sequence to the right here, I know my initial value would be $10,000. And I'm going to multiply that by the common ratio of 8,000 divided by 10,000. Well, 8,000 divided by 10,000 is equal to 0.8. I'm going to raise that to the n minus 1 power. And then it asks me how much the car is going to be worth in 8 years. So that's going to be 10,000 times 0.8 to the 8 minus 1 power. So that's 10,000 times 0.8 to the 10 minus 1 power. And that means the car after 8 years is only going to be worth $1,342.18. All right, guys, we will continue on with applications of these exponential functions after this video.